8 minutes and 20 seconds. That's how long it takes for sunlight to reach Earth. About the time it takes to microwave a bag of popcorn. You'd never guess that the sun just vanished. For those 8 minutes, everything looks normal. The sky stays blue. The birds keep singing. You're still scrolling through your phone, unaware that the star at the center of your solar system has simply blinked out of existence. That's the unsettling part. The sun wins by every measure. Its light, its gravity, its warmth all still reach you, right up to the last second. Then, nothing. The sky goes black. Not night, not twilight. Absolute, starless black. The moon disappears because there's no sunlight to reflect. The planets vanish. You're left in a void, drifting. But the real chaos hasn't even started. What happens to Earth in the minutes, days, and years after the sun disappears? The answer is more brutal than you think. This is the countdown to a frozen world. You are sitting in daylight. The sun is a constant warm, steady, familiar. But in this moment, it is already gone. You just don't know it yet. For 8 minutes and 20 seconds, Earth keeps spinning as if nothing happened. Birds still fly. Waves still break. The planet orbits a ghost. Because gravity travels at the speed of light, the same speed as sunlight. So Earth still feels the sun's pull. It still holds its curved path through space. The illusion holds. Picture a microwave timer counting down. That's your window. At 0, the last photon that left the sun's surface finally reaches Earth. Then, nothing. The sky doesn't dim gradually. It snaps black. Both hemispheres plunge into darkness at once. No twilight, no warning. The moon, still reflecting light that left the sun minutes ago, glows for a few more seconds. Then it too goes dark. You look up. The stars are still there, cold and sharp. But the sun is a void, a hole in the sky where warmth used to be. But what happens the moment the last ray of sunlight fades? You know the sun is gone the moment you see it vanish. But here's the strange part. You'd still feel its gravity. Light and gravity travel at the same speed, 8 minutes and 20 seconds. So for that brief window, Earth keeps orbiting a ghost. The planet curves along its path, pulled by a star that no longer exists. Then, at the exact same instant, the sky goes black and the orbit dies. Earth stops bending. It shoots off in a straight line, like a stone released from a sling. Picture that moment. 1 second, you're in daylight, circling a warm sun. The next, you're a rogue planet, hurtling into an abyss. No warning, no transition, just the sudden end of every familiar force. But the real question isn't about the planet's trajectory. It's about what happens to everything on it, the oceans, the air, the life. 8 minutes and 20 seconds is enough time to finish a short coffee break. After that, the clock starts ticking on a very different kind of countdown. What does this mean for life on the surface? Subscribe to survive the next cosmic catastrophe. The last photon left the sun 8 minutes ago. Now the heat stops. You feel it first as a strange stillness. The wind doesn't howl, it dies. Without the sun's infrared radiation warming the atmosphere, the air begins to cool from the top down. Within hours, the surface temperature plummets. But the oceans hold a secret. Water is stubborn. It stores heat, releases it slowly. For a few days, coastal cities feel a false reprieve. Then the freeze sets in. Ice creeps from the poles toward the equator. Within weeks, the ocean's surface solidifies. But not all life dies immediately. Deep beneath the waves, hydrothermal vents still pump superheated minerals into the abyss. Bacteria thrive there, feeding on chemical energy, not sunlight. They will outlast everything on land. The planet becomes a frozen rock, but the embers of life still glow in the dark. You stand on the surface, wrapped in every layer you own. The cold is absolute. Your breath freezes before it leaves your lips. How long could humans survive this deep freeze? The surface freezes first. Ice spreads from the poles toward the equator, a white crust creeping over the waves. Within weeks, the entire ocean is sealed under a lid of frozen water. But below that lid, the depths remain liquid. Water is strange. It holds heat. The deep ocean, insulated by miles of pressure and darkness, cools slowly. For months, maybe longer, a hidden world survives. Creatures that never see light, that feed on chemical vents or decaying matter, continue their slow existence. They do not know the sun is gone. They never knew it was there. But the surface freeze is not just a lid, it blocks gas exchange. Without sunlight, phytoplankton die. The oxygen they produce vanishes from the atmosphere. The ocean's upper layers become anoxic. Fish suffocate. Whales, seals, anything that breathes air finds no open water to surface through. The ice traps them. The cold kills them. Yet the deep-sea vents still pump heat and minerals, tube worms, shrimp, bacteria. They thrive on chemistry, not sunlight. They could outlast the surface extinction by years, but they are few. They cannot sustain the global food web. The ocean does not save us. It only delays the end. What about the creatures that rely on sunlight? But deep beneath the frozen surface, something still burns. Earth's core remains molten, a sphere of iron and nickel, still churning from the planet's formation. That heat radiates upward through miles of rock and reaches the ocean floor. Hydrothermal vents continue to spew superheated water, rich with minerals. In these abyssal oases, life does not need sunlight. Chemosynthetic bacteria thrive on sulfur and hydrogen. They form the base of a food chain that could persist for millions of years. Yet this is not a second chance for civilization. The energy available from geothermal sources is staggeringly small compared to the sun. It could sustain a few scattered ecosystems, extremophiles, tube worms, blind shrimp, but not a global biosphere. No plants, no photosynthesis, no oxygen replenishment. The atmosphere would slowly freeze and fall as snow. The oceans would become a solid shell of ice, kilometers thick, pressing down on the last liquid water. Only the deepest trenches, where the core's heat still melts the ice from below, might remain habitable. A few pockets of life, clinging to volcanic vents, isolated in eternal darkness, but they would evolve in strange directions. What would the final survivors look like? The first year passes in a deepening cold. By month 6, the oceans are frozen solid to a depth of hundreds of meters. The ice cap spreads from pole to equator, swallowing the last patches of open water. But the deep sea still holds heat. Hydrothermal vents pump warmth from Earth's core, creating isolated oases. For a while, chemosynthetic bacteria survive there, feeding on sulfur and methane. They are the last living things on the planet. Yet the vents cannot sustain the surface. Above the ice, the atmosphere itself begins to freeze. Carbon dioxide snows down, then nitrogen liquefies, then oxygen turns to pale blue crystals. The air becomes a thin, cold ghost. By year 2, the average surface temperature hovers near -200 degrees Celsius. No organism can endure that. Even the hardiest extremophiles, the tardigrades, the deep-sea microbes, eventually succumb as their liquid water turns to glass. Earth becomes a frozen graveyard, a dark, silent sphere drifting through the void. The moon still orbits, but without the sun's light, it is just a black rock against black space. No wind, no sound, no movement. The only warmth left is deep inside the planet, where radioactive decay keeps the core molten for billions of years. But that heat never reaches the surface. It is trapped, useless, a memory of the fire that once powered a living world. So the question hangs in the absolute dark. Is there any hope for a comeback? You have exactly 8 minutes and 20 seconds of normalcy. That's how long it takes for the sun's light to reach Earth, roughly the time to microwave a bag of popcorn. But gravity travels at the same speed. So for those same minutes, Earth still feels the sun's invisible pull, still traces its ancient orbit as if nothing has changed. Then the clock hits 0. The sun is gone. Not hidden, not dimmed, gone. Earth doesn't stop. It doesn't slow. It simply leaves, shooting off in a straight line from the last point of gravitational influence, like a stone released from a sling. Both hemispheres plunge into absolute darkness at the same instant. No twilight, no dawn, just a black sky where the star used to be. Temperatures drop fast. Within a week, the surface is below freezing. Within a month, the oceans begin to ice over from the top down. Most life doesn't stand a chance. Plants die without light. The food chain collapses from the bottom. The planet becomes a rogue world, carrying its frozen cargo through an endless night. The lesson is brutal, but simple. The sun is not a luxury. It is the engine, the anchor, the clock. Without it, Earth is just a rock with momentum. And momentum alone cannot keep you warm. But what if the real monopoly isn't a board game, but the control of the last energy source on a dying planet? That story is darker than you think. Stay curious, stay prepared.